So welcome everybody to my talk about the things nobody wants to do. Or if you work in AAA company with own engine, you probably have some of those systems. Or you didn't wait for Epic to do their job and created your own component systems. So presentation, mass and epic way of ECS. Maybe I can change your mind if you're not using the ECS yet, because this way can speed up your games in certain scenarios, and we'll see if you get convinced to change your mindset about that if you are opposed to that ECS idea. So here's my plan here. Introduction, motivation, ECS history a bit, then architecture of mass entity system, so the ECS way in Unreal Engine, then the basic implementation and how mass entity cohabitates with other Unreal systems, a few useful cases, summary, and there will be time for questions and answers. And will be like the introduction to the system. But it relies on the latest version, so 5.4. There were some changes, and also I will mention that again later in the presentation. In a few weeks, I will publish the example project where I'll try to present exactly on a simple examples the way that you can implement ECS into your project without this whole overblown example of a city sample that is useful and it is nice, but it's really overcumbered in my opinion. So let's begin, and for starters, please do enjoy the presentation if you can, and note your questions, but you don't have to take notes if you feel need to, because entire presentation will be available through a simple link and QR code at the end. So if you don't know me, hello, my name is Grzegorz Wątroba. I'm a programmer for around 14 years now. I did a bunch of projects for different platforms, multiple engines, blah, blah, blah. And I work with those companies. And yeah, so enough of the introductions. So why even bother to think about ECS? We tend to rely in gameplay and systems mechanics on single main thread, and sure, we have a networking thread, audio, render, but aside from workload on GPU and preparing draw calls, the most of heavy lifting is still left in the main thread. Also, modern CPUs in our PCs and consoles have like 8, 12, 16 or even more threads to work with, multiple cores and so on, so we often do not use it at all. So at some point or scale, we become CPU bound, and we have like bunch of really good ways, methodologies and tools, and to reduce the GPU boundness, and it's fun and it's really important. But I think we do tend to forget about some places and some types of projects when we really can become CPU bound, and then any upscaler or any GPU trick won't do. So we have to at some point think about CPU optimization. And why we do have those problems. So we have a high granularity of structures. Current programming paradigm in games is mostly focused about object-oriented programming, so we conceptualize things more naturally, like as we perceive in our surrounding, right? So we have some object actor to which we attach some properties and functions, and each object is a bit unique, and in a small scale projects it's like totally fine. But in projects where we have multiple actors and they are all active and interacting in environment, we spot a few major problems. So memory fragmentation, call overlap, and problems with utilizing those multiple threads. And if you want to have like hundreds or thousands of actors doing similar things, the overlap can completely kill off our performance. And when we use object-oriented approach, we instantiate different properties and objects at different times, allocating memory in fragmented way. And because of that, CPU is using additional work to and additional cycles to access specific places in memory, loading, prefetching stuff in CPU cache. And this is like one of the biggest problems in that area. And if you think that you've seen the summer, it's because of my older presentation regarding Unity. And yeah, because the problem with architecture is the same. And in a data-oriented paradigm, data is of specific properties held next to each other, which allows to utilize more CPU tricks due to CPU prefetching, and we can vectorize code, we can create multi-threaded processes more easily. And in object-oriented programming, we treat those objects individually. That results in finding each object first and then calling its own action loops, accessing every property, and this wastes CPU cycles even more. And this approach is also not thread safe because two separate threads might access the same location, so we have racing conditions and other problems. So in data-oriented approach, we load data as a group, and from single point, some manager or so, we call update on all those code objects per chosen group. And this makes like our life easier in terms of multi-threaded computation. Since we control the entire block of actors and its properties at the same time, which is placed next to each other, and that allows us to set a range of operations for each thread much easier and safer. And so where did all approach start? So a bit of history. In 1998, Thief, the Dark Project, this is like the first historical usage, or at least that's what Wikipedia says. First usage of ECS, then it was used in Thief 2, System Shock 2. Then the first like proper terminology and concepts were described by Adam Martin in 2007 in Operation Flashpoint Dragon Rising. Then in 2015, Apple introduced ECS in their gameplay kit. In 2018, in August, Sundar Mertens created Flex. So this is really neat framework. Then in October that year, Unity released first Dots Megacity demo, and it was really nice too. And then in 2021, Epic released Matrix Awakens demo, which showed there the mass entity system. It was all experimental. And now, since 5.2, the mass entity system is production ready. I think it is described that way, but some of the other additions to that system are still experimental. Still, some of the studios already used it in commercial products and they work quite well. Also, like I said before, lots of system-heavy games use it. So Larian Studios uses as ECS. Techland has its own probably the same system from what I've heard at least. Also, yeah, I think all major studios that have projects in larger scale have some form of that system because it's like a logical thing to do. Then the entity component system. What is it? So it's a software architectural pattern used in game development and other real-time applications. It's designed to organize and process entities, which are objects in a game or simulation in a way that's efficient and flexible and scalable. So the pattern here is well suited for a system where we have a large number of objects doing similar calculations and interactions with each other. So this system is perfect for multi-agent elements and environments such as pedestrian movements, traffic, some like in Baldur's Gate 3, we have a lot of characters that can interact with each other, and they have own day and night systems and so on. And there, for example, you have lots of things to process. Even though you don't see them, they do have some workings in the background, so this is the perfect way to process them. Also in physics simulations, it's also great. So let's explain the elements of this system. So the architecture, so to speak. So entity in ECS, the entity is a like general purpose object. It's a typically an ID of sort, like entry in database that aggregates components but doesn't contain any data or behavior itself. So it's like the keychain. So it doesn't have like the meaning itself, but with other elements it means something. Then components are plain data structures that contain data relative to specific properties. So position, health, velocity, and they are attached to entities and define their properties or state. And then we have systems. So systems are the actual mechanics, so the logic behavior of the game or application where these entities reside. So each system processes entities and have specific set of components, performing operations based on the data in those components. So this is like the concept of it, also from my previous presentation about Unity's ECS. The primary goal of the ECS is to decouple data or components from behavior, so the systems, leading to a more flexible and maintainable and performance optimized architecture. The separation allows for easier scaling and iterating on game features, as well as efficient use of hardware, especially in terms of parallel processing and cache utilization. Then, so how all of this is integrated into Unreal Engine. So of course Epic had to do things a bit differently. But they have a point. Since we already have like common concept of components both in Unity and Unreal, they had to create like more strict nomenclature, and it makes sense. So entities are named the same. So the basic unit in mass entity is representing individual agents in a simulation, but instead of a component, they have fragments. So those are data structures attached to entities, storing attributes, and this is the equivalent of ECS components. And fragments contain structures, enums, other complex data types, but it is advised to use plain old data and not references or something like that. Also, archetypes are collections of entities with identical fragment compositions organized in memory chunks for performance. Then they have processors, traits, and queries. So processors are stateless classes that provides the logic for manipulating fragments of entities, and processor is equivalent to ECS system. Traits are like complete functionalities. So it makes sense in terms of better organization of all mechanics in the engine. And this is collective name for both fragments and processors, and each entity can have multiple traits. And then a chunk is a collection of entities that share the same archetype. And in addition to that, we have queries. So they filter and iterate entities based on fragments and tag requirements. So there are a lot of definitions, but like in the plain old sense, we have entity, we have fragments, so there are like the properties of the objects. We have processors that like process things, well, right? But before we run the processor, we have to extract which entities we want to process. And to do that, we can filter them out through queries to get to know the processor, which entity is eligible to be done through that system. And if we want to separate them in additional way, we can add tag to them. So that way we know, for example, that if we want to have like a very specific way of separating objects that might be the same or have the same fragments, we can still do that. And this is like the addition to the traditional ECS system, but it makes sense in certain scenarios. And processors define queries in configure queries function. Processors execute queries in their execute function, and queries are executed by calling for each entity chunk with a lambda function. So most of the processes is when you define the processor class, you have there this for each call, and in it you embed the lambda with actual logic. So it sadly is a bit of boilerplate at the beginning, but still if you like get to know the system or like get into the flow of writing all of this code at the start, then you know you can just copy paste stuff and only change the logic. So Unreal utilized the coupling of data and functionalities on an internal level, as well as why there are several subsystems for managing different areas of mass entity system. So mass representation subsystem is responsible for spawning and managing visual aspects of entities. Then mass actor spawner system used for spawning actors via a UMass actor spawner. And through that class, actually, you create entities on the scene. Then you have mass actor subsystem for actor tracking, mass agent subsystem used for actors with mass agent components. So if you want to join the classical way of having objects and mass entity systems, and those are allowing you to communicate between those two worlds, so to speak. Then system, depending on the chosen setup and properties, can automatically scale in terms of multi-threading. So if you set up all those stuff and run it, it will automatically, if you don't change the specific way of configurations, it will automatically take as much place as you have in terms of threaded resources. So if you have, for example, I know 20 threads in your PC, then you use some for like standard stuff, so those 5, maybe 6 threads for like rendering, physics, and so on and so on. But the rest will be distributed for this mass entity systems automatically. So this is really, really neat in my opinion. And there are automated points of synchronization, and you can decide which processor is done first. That's why you can control all the process. And yeah, this is also really useful for debugging and so on. So fragments, archetypes, and traits can be nested to provide the elastic way of designing elements of the world. So you like create those groups of functionalities more to be like the classical way of organizing objects in the world. Fragments and subsystems are accessed based on the access requirement defined in the queries, so it's all controllable in every possible way. Performance considerations. So it's designed for efficiency through batched iterations of archetypes. Fragments should contain plain old data, but it is not required. But if you create really big amount of references, you will waste those cycles to actually find the way to the actual data. So don't waste your cycles. Try to use plain old data. And also processors and queries should be designed to minimize cache misses. And it is all connected more with the large scale projects. So if you have really like individualized systems, and you have, for example, I don't know, the like playing all adventure game where you don't have many moving agents and so on, it might be useless to use actually the mass entity, because the overload of this initial setup might not be beneficial for your game. So it's not like universal solution for everything. Also, mass framework is a powerful but complex system. So the biggest thing and the biggest challenge, I think, is to change the way you think about organizing objects. And this is I think, the biggest drawback of all of these systems. Then, so how can we start playing with ECS in Unreal Engine? So one of the starting points could be City Sample project from Epic itself. It contains all the basic toys. We need to test out possibilities of the system to either use it or start it from scratch. Though all we need to do is to install mass-related plugins. Mass entity for starters, of course, it's the main plugin, but you have also mass gameplay, mass AI, mass crowd. So all of those are additional toys. They're all experimental, aside from the mass entity plugin, which is now, like I said, production ready. Then what would be our initial implementation of that system? So we can set up traits that are already made from plugins, or we can create our own derived from UMass entity trait base. But first of all, we should create mass entity config, which can be connected to the spawner or specific agent we attach to our game object. And then we have to set up traits. Then after that, we have to place mass spawner and set up entities and proportions. So how many objects of that set quota are we generating through given spawner? And count in spawner describe all entities generated from given spawner, and proportion from each config should sum up to 1. Don't have to, but it is advised to do that. Also, then we set up generators, and we can set up ready-made ones and fill up their requirements. So, for example, zone graph, and we can like generate pedestrians along the zone graph because we want to have the crowd moving along some like roads or something. But also we can create our own and create our own rules regarding that. And it is derived from UMass entity spawn data generation base, which the generate code itself is not that complicated. Then we set up fragments and automatic processor registration. And again, we can use ready-made ones or create our own derived from f mass fragment. And you have to set it up in config data asset as a separate trait called assorted fragments, because you have several ready-made traits that will include needed fragments. But if you create your own, you have to add it in assorted fragment traits. So the whole system will know what elements can be expected in all configuration. Also, some of the processors by default do not register automatically in the system, and you have to then create your own subsystem to control it, or just go to the project settings and then check whether you have auto register with processing phases option checked. Also, you might what might be important and worth experimenting with and check requires game thread execution. Expect crashes in certain cases, of course, but if given processor won't, then it means that even the initialization phase might be done on separate threads. It doesn't work on animation, definitely. if you want to set up the anime instances and so on, it's still required to be done on game thread. And after all that initial setup, you may generate hundreds or even thousands of units. You can use many from the starting content pack, or use BP and ABP of your own. Yeah, so the simplest way to test it is to create a simple crowd system. And also, this will be like my sample project I will publish in a few weeks that will use actually those the simplest element from starting content that will be chopped down to the simplest example to show that it works and it's not that complicated. At this point, we're not with this setup. We're not there yet with performance as we use high-res objects, but if you take a peek at Unreal Insights, even after this initial setup and this config setup, if you look at Unreal's profiler, you will notice that entity-related calculations are already evenly spread among all threads. So at first point, if you set up this thing and you haven't had any contact with ECS before, you might have this feeling of it's just that, or how that's even possible without setting up threads, setting up synchronization points, and so on and so on. And yeah, that works, and that's really funny, I guess. But it really is not that much. And if you follow like the simplest tutorials, you won't even have to write much of the code itself. So. Does mass cooperate with other UE system? Of course it does. In most cases, we have at least like the three types of elements if we want to have this mass and non-mass objects in the game. So we have standard actors, then we have mass-controlled actor. So actor spawned from a mass spawner that has individual representation and fully animated skeleton mesh and so on. And then we have mass entity that is fully processed by mass system element placed in the scene. So in most cases, closest actors should be those fully rigged characters, mass-controlled actors, and the more distant ones should be custom generated, vertex animated static meshes using mass entity, because that's like the most performant thing to do. And you can do all that and manage that through, for example, Significance Manager. And mass entity can coexist along the standard objects and other systems like I said, Significance Manager, which can conveniently manage all of those objects. So to see how this Significance Manager work, you can look at my presentation from 2022, I guess. Animate the entire city in milliseconds using UE4, because there are some examples how to do that. And also with this example I'm producing now, there will be like showing the way that mass entity system and Significance Manager work along each other with other animation optimizations and so on. So let's adapt animation blueprint to mass entity. Firstly, we have to add mass agent component to our existing blueprint. Secondly, we have to create a new config and add traits for agent movement sync and agent feed location sync if you want to have movement adapt. And we have to set sync direction of agent movement sync to be mass to actor, and agent feed location sync to actor to mass, because this is like the way to signal specific data to specific system, for what we want to send to mass system and what we want to take from it to use it at our advantage. Then when using the actor to mass sync direction, it allows mass to react to the world, affecting the agent's location. Notable use cases include the agent being bumped by other actors or being moved by physics such as, I don't know, platforms or something. So let's do a few more simple things before wrapping this up, because we have like 15 minutes left. So when we scale up, we need to think about performance both on CPU and GPU. But if we are far away, we do not need like fully rigged high-res characters. So it's beneficial to set up low-res version and LODs. So first of all, create low-res actor blueprint, and that uses simpler skeleton and animation set, less instructions and so on. So then in visualization trait, set low-res blueprint to low-res template actor, and in LOD representation, set low-res actor to medium, low to static mesh, none to off. And lastly, in LOD parameters, you can set appropriate distances, how they will be processed within that whole crowd system that we're building here. Then, after we have this basic setup, which resolution of the object will be used at a certain point, we need to pass that LOD information to mass entities, and we have LOD collector trait for that. And mass viewer info fragment is also used there automatically, so we have to check whether we need to have that set up in assorted fragments. Also, the thing is that in all mass entity config, we have validate config button that will tell us if we are lacking of certain fragments or we have too much of them set up. So it makes life really easy with this entity setup. And also, what would be a crowd without a navigation system? So you have a bunch of different ways to set up navigation type fragments. So to have it like using, for example, the zone graph, which is the simplest way actually, and this is used in the city sample. You have to add traits: movement, steering, avoidance, smooth orientation, and agent radius fragment in assorted fragments. And movement allows for movement parameters to be set for the entity and move along the zone graph. Then steering allows for parameters to be set that control steering behaviors such as reaction times, speed threshold, and move targets selection cooldowns. Then smooth orientation allows us to regulate how quick actor will rotate and react. And avoidance allows us to for agents to avoid obstacles. All of those parameters are really, really extensive. And crowd management is topic for like separate lecture, but maybe next year I'll create the comprehensive set for it as well. But like I said, follow me on socials, and I will try to produce the most like basic implementation that will help you start up even better. Then the best results so far for crowd movement, like I said, is achieved through zone graphs. So if you create one, you can always set up spawner to produce entities along that zone graph and set up zone graph navigation and navigation obstacle traits in entity config, and through that you will have like the basics for movement and the road for units to move actually. Then we would like to, we want our actors to think about stuff and react appropriately to zone graph and so on. So we have all of those elements for state tree. So create state tree asset that derives from mass behavior. And this is like good entry point for mass actor logic. And in state tree asset, set up the path to follow based on those zone graphs tags we created before, and add some idle state, for example. Compile, save, validate, and we're almost there to have our crowd moving. And then we'd probably want to embed our player in that crowd and make it aware of our presence to properly react. Because if you don't do that and you'll just run the simple example, you will bounce from entity component actors, and if you add this bit, then they will try to avoid you. So this is also a good thing to add, and looks really nice to test. So you have to have your own player blueprint. You have to create new config asset, add a navigation obstacle, so the system knows that you are obstacle for the actors, and then agent capsule collision trait. Send sync transform and actor to mass parameters to agent capsule collision sync, and add this mass agent component to your player's BP, and through that the system knows that you are an obstacle for other crowd elements. Then to check if you have any problems, you have extensive tool to debug all of these processes. So Mass Debugger allows to have an extensive look at what is happening underneath the systems. We can check every processor, group, archetype to spot any abrasive point and find inefficiencies, improve performance, and go even further. And like I said before, remember to always validate your config. The log will tell you which fragments or traits you are missing or you're adding too much, because if you add too much to the system, it's overcumbrance in the configuration, so the engine will report that it's not needed. And this is like the simple result. This is like the simple result of the crowd system. So, like in the basic version, when I had like the simplest map, the only like the metahuman generated elements, or simple those many skeletons from the starting content pack I could have on my PC, like between 20 to 100 rigged characters. If you add the significance manager toys and so on, you can have like 100 something characters to keep the 60 FPS. But if you add those mass entity system and move all calculations, or as much as possible, to be multi-threaded calculated, then you can actually scale up even 10 times. Of course, it depends on how complicated your blueprints are, how many animations you have there, how much of additional logic you have there. But you can really scale up significantly if you use a mass system. So depending on usage and how you will rely on mass entity systems, you may reduce the workload of game thread by double-digit percentage. And like I said, I will produce that sample project with numbers, and then you will see what might be the actual percentage gain of those entity component system usage in Unreal. So let's sum this up. The mass entity system in Unreal Engine 5 offers a powerful and efficient framework for developing multi-agent simulations. Its data-oriented design, leveraging entities, fragments, processors, allows for scalable and high-performance simulations. It's not that hard to actually use, but it's hard to change the way you think about constructing the game objects. And the integration with Unreal Engine's broader ecosystem further enhances the capabilities, making it suitable for complex and dynamic simulation scenarios. But like I said, if you don't have large-scale systems in your game, it doesn't make sense. Doesn't make any sense to implement it, because the initial setup is quite heavy. And also there's much of the boilerplate you have to implement, even though you might use the ready-made elements. And for practical implementation, developers should explore more specific requirements of their simulation. So not every element now works perfectly, but it seems like Epic's fantasy for starters was to create efficient tracking, traffic and crowd simulation. So for that, it's quite awesome. And the mass framework is an active area of development, and Epic continues to add new stuff there. While originally developed for crowd simulations, mass has application across gameplay, UI, procedural generation. Also, if you look into the engine now, in version 5 point something, every like basic element underneath is starting to become more data oriented. So I think, in my opinion, that data oriented architecture in general is the future, and like I said, the biggest in the industry, and first party developers use it already. And it was always like really limited for the people that are using the commercial engines, but now both Unity and Unreal have those systems. So it's really worth attempting to implement it in your games, because thanks to that you really become less and less CPU bound. So here you have links, and actually links to the sources I used for my presentation. There are a few separate examples and of a different like detail level, so you can check that out. There are not many sources, like I said before, but I will contribute to that, so it will be much easier to start with. And you can always find me on social media to reach out in person if you have any doubts and remarks, and I will try to publish it as soon as possible. So you have QR code now, then link to the presentation, and let's move on to the QA. And I fit into 45 minutes. So yeah, let's get some questions if you want to.
Hi, thanks for the talk. How easy it is to add or remove some systems or features in runtime?
You just remove the processors from the config.
Okay, so yeah, it should work.
Yeah.
Okay, thanks.
Hi, I just want to ask how far is the replication implemented into the whole mass system?
There are traits for that, and they are preparing for network to be also a part of the replication and used for the networking and so on and so on. But I haven't tried that one, so I don't know.
Okay, thank you.
Okay, I don't see any more questions. So if there is no other, thank you for your attention and have a great rest of the conference.
Thank you, Grzegorz.